Section 6.6, Systems of Inequalities. All right. Solve the system of inequalities by graphing. So we are given two inequalities here, and we need to graph them in order to figure out the two solutions. So if I look at that first inequality, 5x plus 2y is greater than or equal to 10, that inequality cannot be graphed the way that it is because it's not in slope-intercept form, y equals mx plus b. So in order to get it into slope-intercept form, I need to circle my 2y and bring my 5x to the other side by subtracting. So those cancel. And then on the right-hand side, I'm left with negative 5x and 10. Remember, you cannot combine those because they're not like terms. And I like to write the slope number first, which is the one with the x. Then in order to get rid of the 2 next to the y, I need to divide every single number by 2. So I'm left with y is greater than or equal to, negative 5 over 2 is not a nice number, so I'll leave that as a fraction, and 10 over 2 is 5. So here is the first inequality I am going to graph. So my y-intercept is 5, so go up 5 on your y-axis. And then your slope is negative 5 over 2. So down 5 over 2, down 5 over 2. Now remember that greater than or equal to and less than or equal to need a solid line. So I'm going to make a solid line connecting my points. And then my inequality is greater than or equal to. Greater than or equal to means I need to shade up. So if I go to my y-intercept and shade up, I'm going to make O's above my line. Okay. Then if I look at the second inequality, y is less than 1/2 x minus 3, that's already in slope-intercept form, so it is ready to graph. So my y-intercept is negative 3, so put my first point at negative 3, then rise 1, run 2, rise 1, run 2, rise 1, run 2. That one is less than and greater than need a dashed line. And my inequality is less than. So less than means I need to shade below. So I'm going to put x's below my line. Now I'm going to look at where do my x's and o's overlap. Well, they overlap in the bottom right-hand corner. So this right here is my solution area. So I'm going to shade in this area. So any ordered pairs that fall in this area would be a solution. So let's name 2 ordered pairs that fell in that area. So if I go over 1, 2, 3, 4, 5 and down 1, 2, that right there would be a solution. So over 5, down 2. And if I went over 6 and down 4, that would also fall in the solution set. Now remember that you can pick any 2 ordered pairs you want. Also remember that any ordered pairs on your dashed line are not a solution, and any pairs on your ordered pairs on your solid line are a solution. So for example, this would be a solution, but these 2 would not. All right. First inequality on this one is 3y is greater than 2x plus 6. That is not in slope-intercept form, so I'm going to need to solve it. Now this one we don't have to subtract anything. All we have to do is get rid of the 3 that's next to the y. The opposite of 3 times y is dividing. So I just have one step on this problem and it's dividing. 2/3 does not divide nicely, so leave it as a fraction. 6 divided by 3 is 2. So my y-intercept is 2, so put your first point there on your y-axis. And then your slope is 2/3. So rise 2, run 3, rise 2, run 3. All right, and then this is greater than, so greater than is a dashed line. And then greater than, you also shade above. So I'll put my circles above. All right. And my second inequality is already in slope-intercept form. So I can start by putting my first point at 5 on the y-axis. 1, 2, 3, 4, 5. And then my slope is -3/2. So down 3/2, down 3/2, down 3/2. Greater than or equal to is a solid line. And then, less than or equal to is a solid line. And then less than, so that means I need to shade below my line. So then where my X's and O's overlap in this one is this section here on the left. And then some ordered pairs in this area, -3, 2. And -4, 0. And then again, any ordered pairs that fell on my solid line, like here and here, would be solutions. Anything on my dotted line is not a solution. All right, one more. This time, neither of the inequalities are in slope-intercept form, so we are going to have to solve for both of them. So 2y is greater than or equal to 4x minus 6. Divide everything by 2. And we have y is greater than or equal to 2x minus 3. So y-intercept is -3. And then rise 2, run 1, up 2/1, up 2/1. On a solid line, because it's greater than or equal to. And then greater than means shade above. All right, second inequality. So -2y is what I want to get by itself, so I'll subtract 6x on both sides. Remember, keep these separate, write your slope first. And then divide everything by -2. Now we have to remember that anytime you multiply or divide by a negative, you have to flip your inequality sign. So I switched it from less than to greater than. So it's y is greater than. -6 divided by -2 is +3. 12 divided by -2 is -6. So y-intercept is -6. 1, 2, 3, 4, 5, 6. Slope is 3, so up over 1. These are very close to each other. All right. And then on this one, it is a dashed line. Okay, and then on that one, I need to shade greater than, so up. So my shaded area on this one is a really big area. It's everything in this area. So we kind of have a couple little, like this area right here is just being shaded by from the blue line, and then this area up here is just being shaded from the green line. So that was a little tricky. Okay, 2 solutions. I'm gonna name some easy ones on this one. 0, 0, and we'll do 1, 1.